It's sleeping like on the ground.
Okay. So code today is 275. And we're gonna discuss how to do the next lab. So the lab before this, I forget what it was. It's not the tennis ball. What was the lab before this?
Something to do with Cypress. It's like the dartboard.
What was the topic? What did I call it? I just remember it was a little bit shorter. But anyways, for the next 2 weeks, because we have 1 week off, starting Friday, this next lab is kind of just making functions because the lab is supposed to be focusing on writing tests. So in order to write tests that are meaningful, you have to make functions that are meaningful. So you're going to be mostly manipulating images again. There's a few functions that you're going to make. And all of them you have to make by yourself, except for the last one. The last one is extra credit if you make it by yourself. So you are not supposed to be using any built-in MATLAB functions to do these things. So the first one is just making the image grayscale. So I am assuming at least some of us know how to do this already. What is your assumption?
Like setting all the RGB values to the same amount, but that can also vary on the tricks.
Yes. So all of the RGB values will be the same for the same position. And then the question is, what do you make the RGB value? Yep, it's just the average. So just average R, G, B, and then set R, G, and B to the average. So this one is fairly simple, and you can do it without using for loops. So I would encourage you to try and do it without using for loops and only using the array indexing. You remember why we want to do that? Why do we not like for loops? Or while loops?
Is it easier to run with using without using for loops?
It's just faster. So for loops are not as optimized in MATLAB, but the array indexing is. So if you can use array indexing, you should use array indexing. Okay, so the grayscale is straightforward. Yes. The next one. I have 2 slides on grayscale. Okay, I need to leave that. Next one is flipping. So you're gonna do flipping in 2 ways. You're gonna flip an image left to right, and also you're gonna have a function of flipping it up and down. But the concept is the same. So let's just go over flipping in general, and maybe we'll talk about left to right. But the concept will be the same for up and down. So how do you think we would do this? Uh-huh. But how?
Isn't there a function which,
You're not supposed to use this built-in function. Yes.
I mean, I'm thinking of it kind of like an array, kind of like functions. Wait, no, like flipping an array. So it's like where x equals 0 and x is the greatest, and you take those two columns and you swap those, and you just
Huh? How are we gonna swap them? We're gonna loop through it. So we need a for loop. We need to loop through. And there's many ways that we can loop through this, but let's go with Mason's idea. Let's loop through. And if we're doing left to right, we'll loop through the columns. If you were flipping top to bottom, you would loop through the rows, right? So should we loop through all of the columns? Yes. We only need half. And then what if we have an odd amount of columns?
use that little column.
Yes, leave the center alone. So you're gonna do half, and you're going to take the floor of half. So if it ends up being 1.5, that goes to just 1. Right? So the floor just means we get rid of the decimals. So we're going to loop through half. And then what do we need to do in our loop? We need to swap columns, right? So how can I swap columns? So let's not make another loop. Let's do what Mason was saying. And we would just use array indexing on the main array to just grab the column. So we're going to grab the columns, right? We'll grab the first one and the one at the end, right? So let's first grab those columns, right? So the first column is going to be, and let's just call it maybe left, would be the image. What's my first index value? The first index indicates it indicates what row, right? So I need the entire, all of the rows. And I want the leftmost column first, right? So, which is my current index I, probably. So I want all of the rows of index I. That's my left. What's my right? It's also from image, right?
the colon, comma, and minus something?
And minus I. Be careful. What is I? On the first iteration, what is I? So do I want n minus one? I need to include another minus one. Because I want the n, right? So I need, because my indexing in MATLAB is not zero indexing. My first iteration of the loop, I is one. So if I do n minus one, I get one column to the left of the rightmost one first. So I need to offset that with the minus one,
It's -1, but. Oh, okay.
right? Because the second iteration, I will be two. And then two minus one is one, so I'll get the one just to the left of the rightmost. So now I have left and right. How can I swap them?
Another array. Store one column in and then copy.
We have two. We actually have one extra because we're storing it in left and right. I know what you mean though, but
Yeah.
you need some temporary to hold. But we have two, so we have one extra. We wouldn't need to hold left and right. We could just hold left and then put right into it and then put left into what is right. So how are we gonna put left into right and right into left of the image? Where do we want to put the right array? On the left side, this, right? So image. Is. Right? And then. And then when you do that for your half the size for loop, so you're only looping through half. Okay. You'll have swapped all of these on the left side, all of those on the right side. And if you're an odd amount, because we take the floor, you leave the center column alone. It does not move. If you're an even amount, everything swaps. Right? So that's flipping. And you would use the same concept for flipping up and down. It's just now you need to swap the rows. So scaling, you're gonna do two types of scaling. You're gonna scale an image down as well as scale an image up by 2 times. So like if it's a 10 by 10 image, it should be becoming a 20 by 20 image. So we're scaling both the rows and the columns by 2. So overall, our 2D array is 4 times the size, right? So how do we think we can achieve this?
Make it in a where each pixel would present 4 pixels.
Yes. So in order to scale up, we have limited pixel information. So we have to kind of decide how to reuse these pixels. And you're right, so you need 1 becomes 4. right? Because that would translate to overall my image is 4 times the size. So like if we have our image here. This is position 1, 1, right? So if I make it 4 times bigger, position 1, 1 will be the same pixel values as 1, 1 on the other one, right? But to make it 4 times as large, now 1, 2, and then 2, 1, and 2, 2 all have this same pixel value. And then you'll do the same for the next position. So basically you're making 1 pixel become 4 pixels. You're just making it bigger. So your image will not be of higher quality, it'll just be larger. So now the other scaling you need to do is going from bigger to smaller. So say we are from this image, now we want to go back to 10 by 10. What do you think we will do? So how will I condense 4 into 1?
Yeah.
Yes. So we'll just take the average of these 4. And remember, you have to do for R, G, and B separately. Otherwise, if you do them all together, then you're going to end up with a grayscale image at the end, right? The average of the 4 R values together, and that gives you your R value here. The 4 G values together gives you your G value here. 4 B values gives you your B value here. Make sense? And then for the images, they don't like to be decimal numbers. So you'll need to convert them to integers. So you can round, you can truncate, however you want to do it, but just be consistent. Are we good with the scaling?
How would you, like, would you convert it into another?
Yeah, you would make a new. Yes.
So I'm just thinking about the process of it. So like the scale up, it would take like the row and duplicate that to the one right next to it. And same thing with the columns.
The row.
Or I mean, like take a column and then duplicate it and then put it next to the original. And
Not really, because you have to intertwine them. Okay. Because I need this 1 pixel to become this pixel, this pixel, this pixel, and this pixel. So if I just took like a column and then put it next to it, then I have this pixel is the same as this pixel.
Yeah.
But this pixel is supposed to be the same as this pixel.
yeah, and that's kind of what I was saying. And then you take the row and then you duplicate that to the one above it. Or in that case, 500.
So
Like
the
duplicate.
row and also duplicate. I think maybe it could work if you duplicate this row, like your new row. So if you take the row from here again,
Oh, okay.
Any other question? Okay. So the last one is going to be the hardest one, which is why I am doing it in the way that you can use the built-in function to do this one. And it'll help you just be aware of that built-in function and that if you ever needed to do this, and not just for images, but like coordinate plane, same thing applies, right? But if you want to work through this and do it by hand, like with your own code, then it'll be extra credit. So the goal is to rotate the image around the center of the image. So our first challenge is the image itself. The origin is not in the center. Right? So you have your image 1, 1. The 1, 1 is here. 1, 1 is not here. So we first have to convert our position to this new relative coordinate plane. Right? So here is a matrix that will help you achieve converting, like moving positions. So if you see here, this is my position X, my position Y, and for now, this is a 3D matrix, but we're only dealing with 2D. So this would be Z, but let's just ignore it, right? Then if I do the matrix multiplication here, I take this row, multiply it with this column, right? And then I have X plus 0 plus 50. Right? We see that? So that's how I can translate X from 1 to 1 plus 50. Then here I have X times 0, which is 0, Y times 1, which is Y. And then I have right now 0, so it doesn't move. But if I wanted this to move, then I would need to change this value. And then we just don't do anything here. Because this one, we always want the result to be 1. It should just be X times 0, Y times 0, 1 times 1, and we get 1. The only reason that we need this third dimension is in order to add this translation. We see that? Yes.
I'm a little bit confused, like, what are we mean by rotate around the center?
So like, if this is 1 pixel, right? 1, 1. If we wanted to rotate it 180 degrees, then this one should go here. So 180-degree rotation. You're rotating the entire image. Make sense? Okay. Does this matrix make sense for how to move a point relatively. Like all I have to do is, this is how much to move X. This is for Y. Everything else in the matrix just stays the same. And then this is my point. This is my moved point. Right? So this will help us with the translation with where is the origin. Okay, and I'll let you figure out how much to move them by on your own. The next thing you would need to do is rotate. So this is our rotation matrix. We have here cosine of theta, negative sine theta, cosine theta. So if we just construct a matrix like this, and then we matrix multiply a point with this matrix, it will apply that rotation to it. So I'll just make this matrix for us. I have MATLAB just to show you an example. So let's say our point is 1, 2, or 1, 1. Right? So this is our point. And then our rotation matrix, let's make it so it's cosine. Let's say pi. So we're in radians. So rotating by pi in radians is just 180. Okay. Then we have negative sine pi. And then we need a new row, cosine pi, and then cosine of pi, right? Cosine pi. This is our rotation matrix. Then if we do point times rotation, what do I need to? That rotates it. Right, so 1, 1 became -1, -1. You good? I think I have this backwards. Yeah, so that way I don't need to convert it, but still -1, -1. So this is our rotation matrix. You just matrix multiply, just like how if you want to translate, you use this matrix, matrix multiply. So you're going to use these two matrices to figure out this point, where does it end up? If I have my new center is the middle of the image, and then I rotate about that center. Okay. So there's also a function that will do this for you, and you can, I would say, start with that. And then if you have time and you want to express, then you can work on making this function by hand. But in terms of the other ones, you have to do them by hand. And I don't think it would take too long to implement them. And those are the ones that you should focus on writing tests for. And then this one, you would have more tests for it if you implement it by yourself. Okay. Are you good with it? You know what the lab is? We have 2 weeks to do it this time. Okay, so that's what I have for today.